Welcome, wonderful people. This is our second tutorial of implicit differentiation, but this time we will look at finding d squared y over dx squared using implicit differentiation. So we start off with a very simple problem like the one we will have, x squared plus y squared equals 1. So they say use implicit differentiation to find dy over dx and then d squared y over dx squared. Write the solutions in terms of x and y only. So we know this would be d over x, d over dx of x squared plus d over dx of y squared. This would be equals to d over dx of 1. We already dealt with this, so this will be 2x plus 2y d over dx equals to 0. D over dx will be minus x over 1. We dealt with this in the previous tutorial. So this is dy over dx implicitly, so my d squared y will be as follows. Remember, I have to differentiate both sides again, so I have d over dx. I'm differentiating this, d over dx of minus x over 1. This will be d squared y all over dx squared. That is equal. Now factor out the negative. Very good. Now work on this. This will require the quotient rule. You hold on y, you differentiate x, you get 1, minus, you hold on x, you differentiate y, you'll get dy over dx, then you divide by y squared. This is what you will find. Negative, let me just do that. You will have y minus x d over dx divided by y squared. Okay, so I can say, okay, minus y plus x d over dx divided by y squared. But I know the value of dy over dx. Dy over dx is minus x over y. So minus y plus x minus x over y squared. Minus y, positive by negative is a negative, x times x is x squared over y. And all this is being divided by y squared. Very important. So this has a 1, so I can take out an LCD. This into this goes y times this is minus y squared minus x squared. I can change division to multiplication, 1 over y squared. This times 1, it's exactly that. And this times this is y3. So this is my y second prime, or d squared y over dx squared. So this is what I get. For, let me check, what is the problem number? Number 19. For number 19, yes, I get minus y squared minus x squared divided by y3. Now let's go and try to look at number 21. So in 21 we have y squared equals to x squared plus 2x. So the first thing, we will find dy over dx implicitly. So d over dx of y squared d over dx of x squared, factor out 2d over dx of x. Okay, this will be 2y d over dx, 2x plus, we have 2, the derivative of x is 1, so d over dx is 2x plus 2 divided by 2y, dividing both numerator by 2y, you will get x over y plus 1 over y, and thus is x plus 1, which is d over dx. So our d over dx is x plus 1 divided by y. Okay, so this is the first thing that we get. We get d over dx as x plus 1 divided by 1. Now I'm looking for d squared y over dx squared. So d over dx, d over dx, d over dx of x plus 1 divided by y. This is d squared y over dx squared. And here I'm going to apply the quotient rule. So I hold on y. When I differentiate this, I'm going to get 1 minus. Now hold on this, and now differentiate this, you will get dy over dx. Remember, this negative must multiply there. Please do not make any mistake. And all this is divided by y squared. This is very, very important. You hold on quotient rule, you hold on y, you differentiate this, you get 1 minus, then you hold on this, then you differentiate that, divided by y squared. Right, so y times 1 is y, so I have y minus into, remember, I have x plus 1 times dy over dx. My dy over dx is x plus 1 divided by 1. All this is being divided by y squared. I hope we are following. Right, and then from here, where can we go? That's fine. I have y minus this times this. This times this is the same as x plus 1 squared all over y. This times this is x plus 1 squared over y. And all this is being divided by y squared. Multiply by negative, y minus x plus 1 squared all over y. When I multiply by negative, this is what I get. Multiply by the reciprocal 1 over y squared. Okay, that's fine. I can deal with this first. Y, this into this goes y times y is y squared, minus this into this goes once, multiplied by that, multiplied by 1 over y squared. Please don't say this and that because there's a minus there. So let's check something here. This times 1 is the same as y squared minus x plus 1 squared. This into this is y3. Okay, so where am I getting at with this? Where am I really getting at? Now from here, let me just remove the brackets and see what will transpire. Y squared minus x plus 1 all over y3. This is the same as y squared minus, this is x squared plus x, this is x squared plus 2x plus 1 all over y3. Okay, so where do we go from here? Y squared minus x squared minus 2x minus 1 all over y3. This is what I see. I see this. I honestly see this. And this is what I have. And this is what I have. Honestly, this is what I have. I could have just said my answer is y squared minus x plus 1 squared over y3. I could have just said that. But if somebody has a different answer for this, you are more than welcome to share with us. But this is what I have. This is honestly what I have. Okay, that is fine. Let's continue in this. So that was 21, and now let's go to 23. In 23 we have the following: 2 root y equals x minus y. So d over dx of 2 root y equals d over dx of x minus d over dx of y. Okay, so I can factor out this 2d dx of root y equals d over dx of x minus d over dx of y. I can have 2 times this is the same as y to the exponent of 1/2. So I can bring down 1/2, have my y. 1/2 minus 1 is minus 1/2 dy over dx. Because remember, this is y equals y 1/2. Differentiate this, 1/2 y minus 1/2. This is exactly what you will have. But because I'm differentiating with respect to x, I will have dy over dx. And this is equals to, the derivative of x is 1, and this is dy over dx. So numerator and denominator goes once. You are left with this is the same as 1 over the square root of y dy over dx, plus, take this to the other side, dy over dx, and you are left with that 1. Okay, that is fine. So from here, what is it that I can do? I can factor out d over dx, 1 over root y plus 1 equals this. So d over dx, it's 1 over root y plus 1 over 1. Can I try to rewrite this nicely? I think so. So here I can take out an LCD. So I have 1 over, which is root y. Okay. And I can say root y into root y goes once. 1 times 1 is 1. 1 into root y goes root y times 1 is root y. Okay, so I can rewrite this as 1 over 1 plus root y times, there's a denominator, the reciprocal will be 1 over root y. And that should boil down to what? That should boil down to what? Let us try to check. Let us just try to check. 1 over 1 plus, oh, sorry, there's a mistake here. I'm sorry. Now remember, on the numerator we have this, on the denominator we have this. So this is 1 times root y over 1 plus root y. Please be careful there. The numerator is 1. Change this division line to multiplication, they will swap. Please be very careful. So you will have root y divided by root y plus 1 as the value of dy over dx. So your dy over dx is root y divided by root y plus 1. Fine. Now let's go and find the second prime. Right, so dy over dx into dy over dx will be equals to root y plus 1. Are we fine? Yes. So d over dx of this. Okay, this is d squared y over dx squared. Let me just rewrite this nicely. Root y plus 1. So I will apply the quotient rule. So this I will hold on root y plus 1. I will differentiate this. I know that this is 1/2 y minus 1/2 d over dx. Very, very important. So I hold on this, I differentiate that, minus, I hold on this, and I differentiate this. Remember, I hold on this, I differentiated that. Very good. And now I hold on this, now I differentiate this, and I get the very same thing. I get 1/2 y minus 1/2 d over dx. Very important. Divided by root y plus 1 squared. And when I'm here, let me just still say root y plus 1. And now look at the multiplication here. I have root y plus 1. Very good. And this becomes 1 over 2 root y. This is 1 over this. So I have my d over dx. Please be very careful there. Minus, so I'm going to leave this root y times, now this is the same as 1 over 2 root y d over dx. All be divided by root y plus 1 squared. And root y plus 1 all over 2 root y d over dx minus, so I can say this times this is root y 2 root y d over dx. Can you see that? This times this is this divided by root y plus 1 squared. Okay, root y plus 1 2 root y d over dx minus this into this goes once, 1 over 2 d over dx. So let me just go and plug in the values there. Root y plus 1, 2 root y times, what is my d over dx? My dy over dx, I think I found it to be a value of what was it? My dy over dx, I think it was this, the square root of y over the square root of y plus 1. Yes, minus 1/2 times d over dx, the square root of y, the square root of y plus 1. Okay, so what is happening here? This into this goes once, and this into this goes once, and I'm left with 1 over 2 minus, okay, so I have minus root y over 2 into root y plus 1. Let's not forget, right? Let's not forget to divide by root y plus 1 squared. Looking into the numerator, I can take out an LCD, and the LCD will be 2 root y plus 1. So this into this goes once, this times this is root y plus 1 minus this into this goes once, 1 times this is this. Okay, multiply by the reciprocal of this, which is 1 over root y plus 1 squared. And then from here, this is positive, this is negative, goes once, you have 1, we have 1 over 2. When I multiply numbers of the same basis, I add the exponent. Root y plus 1 to the